Here's the solution for F2, the baby elephant problem. A zoo sponsored a one-day contest to name a new baby elephant. I voted for Leibniz. I don't think it's going to win. Zoo visitors deposited entries in a box. Okay, blah, blah, blah. The table here gives us the number of entries that are in the box in hundreds. That's just a little thing to be annoying. Those are in hundreds of entries. Okay, so the function number of entries is capital E. Use the data, this is part A, use the data in the table to approximate the rate in hundreds of entries per hour at which the entries were being deposited at time equals 6. So they want, what we have is a table information about the amount of a quantity, and they're asking us to estimate the rate of change. So that sounds like a slope calculation. They want it at time equals 6. Time equals 6 isn't on the table, but 5 and 7 are. So I'm going to use those entries. So these right here. And I'm just simply going to do a slope calculation. It's right there. Change in y over change in x. You get 400 entries. This is the rise over run turns out to be 4. And remember, that's hundreds of entries per hour. Do they ask about units here? They didn't ask about units, so units were not important. I think it seems like if you just wrote down the answer, the number 4, you're going to get all the credit here for that one. Okay, use trapezoidal sum with 4 subintervals given by the table to approximate the value of 1/8 integral from 0 to 8 of e dt. Using correct units, explain the meaning of that in terms of numbers of entries. Okay, dead giveaway. Keep your eyes open for this. You've got a fraction 1/8 in front of an integral that goes from 0 to 8. That looks like 1 over b minus a times the integral from a to b of f of x dx. That's the average value of the function. Of what function? That's the average value of e. What is e? The number of entries in the box. So what is this expression right here that's circled? It is the average value of the number of entries in the box in hundreds of entries. It's hard to say, but it's pretty clear what that is. It's the average value of E. So, flesh that out. We also have to do a trapezoidal sum. 4 subintervals. Remember how to do that. It's the average of the bases times the height. So there's 2 bases for the first trapezoid, and the height is 2. Take that average, multiply it by the height. The next trapezoid uses those 2. Those are the 2 bases. That's got a height of 3, and so on. So here's their calculation. Make sure that you write that. You have to, if you're doing a trapezoidal sum, they have to see an expression that has all of these plus signs in them so that they know you know what you're doing. So you have to show your work when you're doing a trapezoidal sum or a rectangular sum or something like that. Do the arithmetic, get that right. And then the last thing to keep in mind, they did talk about units. They asked you to supply units. Well, the average value of a quantity has the same units as the quantity. So if you're measuring the mileage in your car in miles per gallon, if you average a whole bunch of trips, your average will also be in miles per gallon. Same units. So this has got units of hundreds of entries in the box. Part C. At 8 p.m., volunteers begin to process the entries. They process them at a rate. Okay, important. That's a rate. Hundreds of entries per hour. None of this stuff above here had per hour to it. So this function that they gave us, the function that describes the processing of the entries, they're sort of pulling them out of the box and counting them and stuff. That's not just number of entries. That's the rate at which those entries are being processed for these 4 hours. Keep that in mind. According to the model, how many entries had not been processed by midnight? Time equal 12. Okay, well, I don't know how many entries were processed just from this, because that's the rate of change. How do you find the number or the quantity when all you have is the rate of change? Well, you really can't. What you can find is the change in quantity by integrating the rate of change. So the integral of this p function is the number of entries that got processed between the 2 times of that integral. Okay, it's the difference in the number of entries that were processed during that time. So here's what they do. They take that integral right there. That's the number of the change in number of entries that were processed from 0 to whatever. So that number right there is the number of entries that were processed, that integral. How many entries were there? 23. Well, of course, that's 2300. So this 23 is the number of entries that was in the box at 8 o'clock. And this is the change in number of entries processed between 8 and 12. It started at 0 entries processed, so this is the number of entries that were processed. If you subtract those two, number of entries in the box minus the number of entries that were processed, that will give you the value. And again, it's in hundreds. Everything here is in hundreds of entries. So you had to know to take the number of entries here and subtract from it the integral of that, because the integral of that tells you the change in number of entries processed. And when you start at 0 and you change by 10, let's say, then your amount is 10. Finally, part D. According to the model from part C, that's this thing right here, at what time were the entries being processed most quickly? Okay, now I lied there. It's not this model. It is actually just this P thing. That's the rate of change, how fast entries are being processed. This wants to know when is how fast going the fastest. In other words, this is a cleverly described absolute maximum problem. You want to find the absolute maximum of the function p between the times 8 and 12. Don't do anything fancy. Do it like every absolute max problem we've ever done. How do you find the absolute max or the absolute min? Well, where can they occur? Endpoints and critical numbers. Here are the endpoints. Those are the 2 critical numbers. How did I get those critical numbers? You had to take the derivative of p and set it equal to 0 and solve. I guarantee you they did that on the graphing calculator when they got these decimals like this. So these are the 2 critical numbers, the time when p prime is equal to 0. You check all 4 of them, endpoints and critical numbers, and you find that the biggest number on the list, the biggest output, happened at time equal 12, happened at midnight. And then you answer that. Okay, so again, p is a rate, that's true, but we're looking for the maximum rate, so you just want to find the maximum, the absolute maximum of p on the interval 8 to 12. All right, that is F2.